Let's discuss question number 37 from test 1. Let's read the question first. A 35 centimeter diameter solid sphere, density is given, is suspended by a cable as shown in the figure. Half of this is in one fluid and the other half is in another fluid. So this is from fluid mechanics. So I'm just writing FM. Okay, so let me just draw it. You have a sphere. Okay. Half of this is exactly half at the diametral plane. Half of this is one fluid. Okay, so this is rho 1200 kg per meter cube, and you have another density which is 1500. So this is rho 1, this is rho 2, this is 1500 kg per meter cube. The diameter is 35 centimeter and density of the sphere, the solid density, is 4500 kg per meter cube, and tension in this cable it is asked. Okay, so what do we do? Any kind of problems, we first draw a free body diagram of this sphere. Okay, now weight is acting mg, tension is T, always pulling up rope, and now half of this is in one sphere. So whenever you have a static fluid and something is immersed, whether it's partially immersed or fully immersed, you have the upward thrust which which comes basically from Archimedes principle. Okay, and the source basically is because of the fluid pressure. Okay, so this is upward thrust exerted by the top fluid. Then from the bottom fluid, because it's in another fluid, the bottom part, so you have the F2, the upward thrust. So these are the forces acting on it. This is stationary, the sphere is stationary, so some of the vertical forces should be 0. Okay, so let's take positive forces upward, so plus T minus F1 minus F2 and mg is downward minus mg should balance each other, and it should be like this. So T is mg, sorry, F1 F2 is upward positive, upward, so plus F1 F2. So when you take to the bottom other side, it's mg minus F1 minus F2. Okay, so how do you find F1 F2? Now here is what we use Archimedes principle. Whenever you have a body which is partially immersed or fully immersed, then the upward thrust that comes is derived from Archimedes principle. So what does Archimedes principle say? It says that the upward thrust or the buoyancy force is equal to the weight of fluid displaced. Weight of the fluid displaced by the solid. Okay, so now if we just consider the top sphere, the top part of the sphere. Okay, so the weight or whatever, if the sphere would not have been there and how much fluid would have been there in that part, the weight of that fluid is what is the upward thrust. So how is so individual upward thrust is driven by weight of the fluid in that submerged or in that displaced volume. So the displaced volume for the top part is, let's say volume of the sphere is, total volume of the sphere is V. Let's say volume of the sphere is V, which is 4 by 3 pi r cube. Okay, so now the submerged volume for the top part or the displaced volume for the top part will be half of it, because so mass of the fluid that can do is density of the fluid of the top fluid into volume is the mass. Volume is V by 2 because only half it is there into G. Okay, so rho 1 V by 2 G is F1. Similarly for the F2, the bottom part, same, we can apply the same principle, but the density is different. Volume is V by 2 into G. So this is your individual buoyancy forces. Now so we want F1 plus F2, the total buoyancy force, which is nothing but rho 1 V by 2G plus rho 2 V by 2G. And now if I just substitute, rho 1 is 1200 into volume, I can write okay, I can basically calculate this, or volume basically becomes V by 2 basically becomes 2 by 3 pi r cube, so that is common, so I can write 2 by 3 pi r is, now diameter is so radius would be 17.5 centimeter, so I can keep as 0.175 in order to convert in meters cube. G is 9.81 plus your rho 2 is 1500 plus into 2 by 3 pi r cube into 9.81. So this total, when I use a calculator, this comes out to be 297.3 newtons. And now when I substitute this value in the equation to get the tension, I get tension is mg. Now this is mass of the solid, and that is again density of the solid into volume into g, minus f1 plus f2, which I already got. So again we need to just substitute the parameters. Density of the sphere is 4500, volume is 4 by 3rd pi r cube, r is 0.175 meter, whole cube 9.81 minus 297.3. so now again using a calculator I get a value 693.7. okay, so it's all about drawing a free body diagram, writing forces, and then upward, always the upward thrust or the buoyancy forces you should be able to find out using Archimedes principle. Okay, so the answer is 693.7, and so close to 694, and the option is C. Thank you.